Hello everyone, welcome back to my channel. And we have already covered, so many chapters of agronomy like introduction, agrometeorology, soil and tillage, soil water conservation. So today we will discuss about dryland agriculture. So what do you understand by dryland agriculture? So dryland agriculture is agriculture practice where we are totally dependent on rainfall, right? We do not have enough irrigation facility available, so we totally depends on rainfall. So in that area where we are totally dependent on rainfall, what type of farming we use, that is known as dryland agriculture. So around 67% of total cropped area is under dryland agriculture, and it provides 42% of total production in India. So major coarse grains and pulses, they mainly grown in dryland agriculture. Around 85% of pulses and oilseeds, they are grown in dryland farming, right? So there are three types of broadly there are three kinds of dryland agriculture. One is dry farming, one is dryland farming, another is rain-fed farming. And let's see the characteristics of these three types of dryland agriculture. So first one is dry farming. So if the rainfall in that area is less than 750 mm, then we can classify that area to dry farming area. Then 750 to 1150 mm, we can classify that to dryland farming. And if the rainfall is more than 1150 mm, then that area is known as rain-fed farming, right? And based on LGP, length of growing period, if in dry farming the LGP is less than 75 days, in dryland farming the LGP is 75 to 120 days, and in rain-fed farming the LGP is more than 120 days. And what are the regions they support? Actually, the dry farming is generally practiced in arid region, dryland farming generally practiced in semi-arid region, and rain-fed farming generally practiced in humid region. And what are the practices, major practices in these regions, in this farming? So in dry farming, moisture conservation should be the major priority. In dryland farming, drainage in vertical should be done. Then in rain-fed farming, drainage of excess water should be our major priority. So in dry farming and dryland farming, soil water conservation, sustainable yield, limited fertilizer and resource use should be practiced. And in rain-fed farming, drainage, yield maximization, high level of input must be done. Then history of dryland farming. First systematic scientific approach was taken by Tamane in 1923 at Manjri near Pune, and that is again passed to Kanitkar. His student was Tamane. First opened the Dry Farming Research Institute at Manjri in 1923. Then the work was passed to Kanitkar, his students, scholar, in 1926. Then Center for Dryland Farming. In 1933, Center for Dryland Farming was opened in Bijapur and Solapur. In 1934, it was established in Hagari and Raichur. In 1935, it was established in Rohtak. Then 1944, monograph on dry farming in India started. 1953, establishment of Central Soil and Soil Conservation Board was done. In 1972, ICAR was established, International Crop Research Institute for Semi-Arid Tropics at Hyderabad. In 1976, establishment of Dryland Operational Resource Projects. In 1983, 47 model watershed were established. In 1984, Dryland Development Board and Watershed Development Project started. In 1985, CRIDA, Central Research Institute for Dryland Agriculture, CRIDA was established in Hyderabad. In 1986, NWDPRA was established. So this is the brief history of dryland farming development, dryland institution development. Then problems of dryland agriculture. What are the problems? So in dryland farming, in dryland agriculture, we are generally there is variable of rainfall is there in terms of intensity, distribution, late onset of monsoon. Sometimes we find early or withdrawal of monsoon, then prolonged dry spell. We also can see. Then soil constraints, we have like alphisol, vertisol, inceptisol, antisols, and there are different soil fertility level. In soil fertility level, soil moisture holding capacity, and soil organic carbon, these are depleted generally in dryland agriculture. Then socio-economic constraints of farmers is also there. So, Kadri Central Arid Zone Research Institute developed India map for dryland area with normal rainfall was proposed by Krishnan and Tanvi in 1972, computed by the climatological water budgeting approach of Thornthwaite and Mather. Actually, Kadri developed a map of dryland area of India, which was developed by Krishnan and Tanvi in 1972, and that was computed based on climatological water budgeting approach developed by Thornthwaite and Mather in 1955. Okay, so crop growing season, okay, depends on soil climatic zone. If water stress are defined as nil or slight water stress if actual evaporation is greater than potential evaporation by 2. When that is when PE by 2, potential evaporation by 2, and the actual evaporation is between PE by 2 and PE by 4, that is known as moderate drought. Then if actual evaporation is less than PE by 4, that is classified as severe drought. Okay. Drought period do not occur in Assam. There are several states where drought generally hardly seen. In Assam, Kerala, East West Bengal. Okay. Aridity is a permanent climatic feature, whereas drought is a temporary feature. Remember, aridity is a permanent climatic feature. Okay, some zones they are known as arid zones, but drought is a temporary feature. What is drought? What is the definition of drought? There are several definitions, but no one is correct. According to Ramdas 1960, situation when actual seasonal rainfall is deficient by more than twice the mean deviation, that is known as drought, according to Ramdas. Okay. American Meteorological Society defined drought as period of abnormally dry weather sufficiently prolonged for lack of water to cause severe hydrological imbalance in the area. Okay. Mainly, what is drought? Drought is the imbalance between soil moisture versus evapotranspiration. So, some classifications are there. Based on duration, drought are classified as permanent, seasonal, contingent, and invisible. What is permanent? Permanent drought generally seen in desert climate. Then seasonal drought is where the well-defined rainy and dry season is there. That is, there we found seasonal drought. Then contingent drought is the abnormal failure of rainfall, may occur in humid and subhumid area also. Then invisible drought, when frequent rain occurs but evapotranspiration is higher than rainfall. Then that is borderline water deficit we can found in those areas. Okay. Then based on nature or relevance to user, we have four kinds of drought: meteorological drought, atmospheric drought, hydrological drought, agricultural drought. What is meteorological drought? When annual rainfall is less than normal rainfall, that is known as meteorological drought. What is atmospheric drought? When low relative humidity with dry hot wind is associated. What is hydrological drought? Prolonged meteorological drought causes hydrological drought, drying of ponds, rivers, lakes, like that. Then agricultural drought, that is based on basically soil drought, imbalance between available soil moisture and evapotranspiration. So what is the plant adaptation to drought? What plants does when drought prevails? Okay, so some plants they escape drought. Those are ephemeral plants or early varieties which duration is shorter. So before drought exists, they just complete their life cycle within 5 to 6 weeks. Another are drought resistance. So in drought resistance, we are basically some are drought avoidance, some some in some case we found drought tolerance. Okay, what is drought avoidance? By restricting transpiration, they actually stops transpiration when drought occurs. There are several mechanisms like early stomata closure, increased photosynthetic efficiency, reduced cuticular respiration, lipid deposition in foliage, reduction in leaf area, then leaf surface morphology, water storage in the plant. So these are certain restricting transpiration. Okay, water saver plants. These are known as water saver plants. Another drought avoidance mechanism is accelerating water uptake or water spender. They have efficient root system, they have more root to top ratio, they have more osmotic potential. These are drought avoidance. Then drought tolerance, tolerating drought. Basically two types: mitigating stress or high degree of tolerance. In mitigating stress, resistance to dehydration is a mechanism, thick cuticle they develop, then they maintain osmotic potential. Okay, in high tolerance metabolic strains, saturation, starvation, acid protein loss is also there. Then plastic strain in some cases. So this is all about plant adaptation to drought. So temperature of normal aridity index and drought condition. If aridity index less than 0.5, then moderate drought. If 0.5 to 1, then large drought. Then 1 to 2, then severe drought, and more than 2, disastrous drought. Okay, then Thornthwaite used water balance approach for evaluating drought and proposed aridity index. We have just discussed about aridity index that was developed by Thornthwaite based on water balance approach. Then Irrigation Commission classified that what is a drought zone? 25% probability of rainfall departure from normal. Suppose there is a normal annual rainfall is 1000 mm, and if the normal annual rainfall is less than 750 mm, then that condition, that situation is known as drought zone. Okay, if this departure is more than 40%, then that is classified as chronic drought zone by Irrigation Commission. Then what are the strategy? Okay, strategy based on weather code and drought code. So moisture conservation in dryland. In dryland, as we know, drought prevails. So moisture conservation is the only measure to prevent, efficiently supply irrigation to households, to plants, and to prevent drought condition. So there are different moisture conservation in dryland methods. So first one is tillage. If we do deep tillage in 2 to 3 years, then the moisture holding capacity will be higher of that soil. Then fallowing in vertical. Okay, we should not tillage the vertical during the kharif season or during the rain period. Okay, then mulching is another which prevents evaporation. Vertical mulching in heavy soil we can recommend. Then in situ moisture conservation are there. Why contour bunding never widely adopted in dryland, and why bunding is last line of defense? Okay, you guys just answer. Find the answer. Okay, so what are the in situ moisture conservation measure? Like broad bed and furrow, where beds are made of 120 to 180 centimeter and effective. This is effective for black soil only. Broad bed and furrow. Then compartmental bunding. Then dead furrow, effective for shallow red soil. Then inter-row water harvesting, more suitable for heavy soil. Inter-plot water harvesting, that is catchment to cultivated area, is maintained at 0.5, suitable for arid horticultural crops. Then scoops we can create, increase opportunity time. Scoops are some small depressions where rainwater deposited, and they gradually percolate inside the soil. Then subsurface moisture barrier like bentonite, clay, tanks, sediments, etc. Then control of water loss. One is moisture conservation, where we can like ex situ moisture conservation and in situ moisture conservation we discussed. Then control of water loss, how we can control water loss from canopy. Like if we can control water from canopy, like we can check transpiration, then we can check evaporation also. How can we check transpiration? Using antitranspirants, right? There are 4 kinds of antitranspirants. One is growth retardant like cycocel, inhibit stomatal opening, PMA, atrazine, etc. Then leaf reflectant, kaolin, silite. Then film forming, mobileaf, hexadecanol. Then we can check evaporation also by using shelter belt and wind breaks. Then mulching, then tillage. Okay, so in these methods we can control water loss. Then water harvesting. So basically farm pond we can create to harvest the water. Okay, farm pond are mainly excavated farm pond, which are circular, maybe square, maybe rectangular. Another is embankment farm pond. Another is excavated embankment. Okay, so factors on catchment area selection. What are the factors while selecting the catchment area? Mainly rainfall, topography, soil, land use, etc. are used as the factors of catchment area selection. So runoff inducement, to induce runoff and to prevent storage loss. Mainly in catchment area, what we do, we just collect water from catchment area and we store in farm pond. So how we can induce the runoff? Land shaping, decrease infiltration rate, like application of sodium, hydrophobic compounds, sodium methyl silonate, sodium broginate, fatty amino acids, surface treatment of bitumen, asphalt, surface cover. These are some of the methods to induce runoff. Okay, and then again, decreased storage loss, lining of farm pond, like natural clay lining. That is recommended like 30 centimeter up to 3 meter depth, then 5 centimeter extra for additional 30 centimeter depth. Okay, this is effective and economic. Then bentonite clay we can apply, like stone, cement, mortar, rubber, polythene sheets, etc. we can apply. Then reducing evaporation, floating wax bar, if we float wax bar over the pond, but this is very costly. Then water harvesting, percolation pond or well, check dams, minor irrigation tanks also we can create. Then protective irrigation. What is protective irrigation? We have to irrigate only once or twice during the crop season to protect it from complete failure, right? 1 to 2 centimeter for shallow rooted crop, then 3 to 5 centimeter for deep rooted crops. Then crop planning. If rainfall is between 350 to 600 mm and the length of growing season is less than 20 weeks, we can plan for single crop only. If rainfall is 600 to 750 mm and length of growing season is 20 to 30 weeks, then we can plan for intercropping. If rainfall is greater than 750 mm and LGP is greater than 30 weeks, then we can plan for double cropping, right? In this way, we can plan crops. Mitigating adverse effect of aberrant weather, we can if late onset of monsoon appears, then we can go for transplanting and alternate variety. We can the finger millet and foxtail millet, they usually response to transplanting. Then if there is dry spell during crop period, then we can go for rattoning, we can go for thinning, we can go for mulching, we can go for weed control and protective irrigation. Then if there is early withdrawal of monsoon, then we can see terminal drought, right? Then in vertical, we can mainly the intercropping system we can adopt, like cereal plus pigeon pea, then soybean plus pigeon pea. In artificial, we can recommend groundnut and pigeon pea, sorghum plus pigeon pea. Major soil groups of semi-arid tropics in India, vertical and artificial are the major soil groups of semi-arid tropics in India. And here in vertical, we can we have already discussed that for intercropping, we can suggest cereal plus pigeon pea and soybean plus pigeon pea in vertical and groundnut plus pigeon pea, sorghum plus pigeon pea in artificial. What is alternate land use system? According to NRSA, cultivable wasteland in India is 38.8 million hectare. In alternate land use system, we are using the land based on its land capability classification. So first one is alley cropping or hedgerow cropping, recommended for humid tropics, alternate to shifting cultivation. This is alternate use of shifting cultivation, alternative use of shifting cultivation. Then alley cropping is also known as hedgerow cropping. So there are three kinds of alley cropping. One is forage alley, one is forage cum mulch system, another is forage cum pole system. Then another alternative land use system is agri-horticulture for arable land, like food cum fruit system. Then horti-silvipasture for non-arable land. Then lay farming for non-arable land. Tree farming for non-arable, like timber fiber production. Then medicinal and aromatic plants also we can grow. Then we can go for agroforestry, that is integrated self-sustained land management system. Then watershed management. What is a watershed? In watershed, what happens? We collect the rainwater in catchment area. Then we just store that rainwater in basin or storage area, and then in command area we just irrigate that water. Okay, that stored water. So watershed is a drainage area on land surface from which runoff from precipitation reach a particular point called common outlet. Watershed management optimize irrigated use of land, water, vegetation. What are the principles of watershed management? Utilizing land based on capability, protecting fertile topsoil, minimizing silting of tank, reservoir, protecting vegetative cover throughout the year, in situ conservation of rainwater, safe disposal, diversion of surface runoff, gully stabilization, increase cropping intensity, alternate land use system, water harvesting for supplying supplementary irrigation, ensure sustainability of ecosystem, maximum farm income, improve infrastructure facility, improve socio-economic status. These are the principles and objective of watershed management. Then component of watershed management, soil and water conservation is one component, then water harvesting is another component, then crop management is another component, then alternate land use system is another component. In soil water conservation, permanent measures, semi-permanent measures and temporary measures are there. So improved dryland agriculture implements, some implements they are used for improved dryland production, cultivation. So FESPO plow, that was developed by CREDA. This is single row bullock drawn fertilizer seed pora plow. Its efficiency is 0.1 to 0.2 hectare per day. Then CREDA drill plow, developed by CREDA. Seed comb fertilizer placement device, covers 0.4 to 0.6 hectare per day. Another is Ridger seeder. This was developed by AICAR PDA HISAR. That is 2 funnel with plastic tube for seed and fertilizer application. Then CREDA seed comb fertilizer drill, that was developed by CREDA. 1 pair of animal is used, 3 person, then 0.3 hectare per hour. This is the efficiency is 0.3 hectare per hour. Doesn't have provision for seed covering. Then Royal Agoru, it was developed by AICAR PDA Anandpur. Then Malabya seed comb fertilizer drill, it was developed by AICAR PDA Varanasi. The efficiency is 0.25 hectare per hour. Shibaji multipurpose farming machine, it was developed by AICAR PDA Solapur. Then CREDA groundnut planter, this was developed by CREDA. That is a 4-row planter. Then Dryland weeder, this was developed by TNAU. Harvesting equipment, single row rotary ripper or wind rower, that was developed by IRI in New Delhi. Groundnut digger, that was developed by CIAE, Central Institute of Agriculture Engineering, Bhopal. The efficiency is 98% even in black soil. Peg type V-shaped groundnut digger, that was developed by Elixir. Okay, so some important MCQs asked in different exam. So agricultural drought when A by PE, actual evaporation by potential evaporation, is less than 0.25. Mechanism of water conservation in plants by Simpson during 1981. Water holding capacity of sandy soil is equal to 100 mA per meter. Transpiration ratio is inverse of water use efficiency. Transpiration ratio is lowest for cam plants. Okay. Mean annual rainfall of dry semi-arid zone is equal to 500 to 750 mm. Moisture index for semi-arid region minus 33.3 to minus 66.6. First person to attempt climate classification was D. Candolle. Climate classification suitable for agriculture was proposed by Troll based on temperature and humid months. Maximum percentage geographical area of India falls under semi-arid dry region. Under mild stress, yield of tobacco increases. Parahelionasty related to pulses. Actually, what happens when there is increase in load of solar radiation, then those leaves of pulses, they actually they arrange themselves perpendicular to the solar radiation, so that radiation load is decreased, and that terms is parahelionasty. Then establishment of rain-fed area of India. Estimated rainfed area of India 95 million hectare. Contribution of southwest monsoon to total precipitation is about 74%. According to IMD, when rainfall deficit is more than 50% of long-term average for a meteorological substation, that is known as severe drought. Severe drought when special coverage is greater than 40%. When the rainfall deviation is more than 50%, deficit is more than 50%, and special coverage is more than 40%. IMD long-term weather forecast model includes numbers of parameters. How many numbers of parameters? 16. According to Anwari system, if production is 25 to 50% of normal, that is called severe drought. Drought-prone area program initiated in 1973. Heredity index 0.5 to 1 means large drought. Vertical mulch at interval 5 to 10 meter. Moisture index for subhumid climate 0 to 20, suggested by Krishnan 1988. Moisture availability index suggested by Hargreaves. And dry farming provides 91% of pulse production. So this is all about dryland agriculture. So guys, I have already posted so many lectures on agronomy, so you can check them out. Thank you guys. Stay tuned.